And here we go, my party people. Welcome in to area and perimeter, the basics. So in this class, everyone, we are really going to be zoning in on understanding why so many people hate this topic. And I'm going to be very, very straightforward here. The reason that people hate this topic is simply because most people try to memorize the formulas and maybe think that that's enough. Most people think that memorizing the formulas and trying one or two questions out, they think that's enough. But it's not. Remember that memorization is just step one. We truly have to understand and apply what we know. Memorization is down here in terms of skills, but understanding and application, that's what we're going to be doing today. And I promise you, regardless of what your skill level is, my goal is to take it to the next step, nice and easy. So number one, we're really going to be understanding these formulas for squares and rectangles, for area and perimeter. From there, we'll be practicing a bunch, looking at a ton of examples, especially knowing how to work backwards from the perimeter or area to get back to the sides. And then lastly, we're really going to focus every single problem that we do. We're going to be honing in on those keywords, the keywords that make a difference, like when we talk about having area in a word problem, but not being told that it's area. Those are those big questions that you can get really easy points on if you know what you're looking for. So again, everybody, 1, 2, 3, we're going to understand the formulas, know how to work backwards, and every step of the way, really focusing on those key words. So let's go ahead and get to our first page of notes. First thing I want you to do is go ahead, write this down, take a moment, and then we will explain our formulas here for a square. So go ahead, write them down, and let's bring it back here and talk about these formulas. So here we are talking about the formulas for a square, and per usual, what I'll do is I'll go ahead and draw my perfect square without the use of technology, because you know me. And there we are, there's our square at the top right. Now, let's talk about the difference between area and perimeter. So, everyone, when we talk about area is how much space a shape covers, how much space it covers. So, from top to bottom, side to side, all of this inside stuff here, this is area. We want to call this space, how much space a shape covers. That's what we mean when we're talking about area. So how much space covered by the shape. And we're talking in 2 dimensions here, because if we're talking volume, then we're talking about 3D space. But for the sake of today's conversation, again, area is the space covered within a shape. When we talk about perimeter, my party people, when we're talking about perimeter of any shape, the perimeter of any shape is going to be the distance covered outside or around the shape. So if we're talking right over here, hey, what's the perimeter of the square? The way that we would calculate it is, let's start in this little corner and just do a lap. That's pretty much it. We're going to go from bottom to the side to the top, top to left, and then all the way down, just like that. So one time, my party people, in the chat box, let me know, are we in accordance here that area is the space inside and the perimeter is the space around? And bring it on forward here. Let's review these formulas one more time before moving forward. So my party people, anytime you're asked for a square specifically, for the space covered or the area covered, you'll use this formula here. You'll take the side and multiply it by itself. Side times side. And when it comes to perimeter, hey, well, guess what, everybody? What do we know about a square? What do we know about all of the sides of a square, everybody? That's right. All the sides of a square are equal. They're all the same. That means that this side down here is the same as this side over here. It's the same as this side over here, and the same as this side right there. So all 4 sides are the same. And so if we're talking perimeter and we're just, quote, adding up all the sides, well, think about it like this. If we're adding up the same thing 4 times, well, that's 4 times the side. So that's why we're not saying side plus side plus side plus side, because 4 times the side is the same exact thing. My party people, before I continue, does that make sense to you personally before we move forward? Excellent. Now I'll give it just a few more moments, about 5 more seconds, and I'll move forward here to the next slide where we're going to be talking about rectangles. Now you're going to see that you're going to, see some pretty similar things happening when it comes to area and perimeter for a rectangle. Pretty similar things. Because when we talk about the area, notice that we are multiplying the dimensions together, the side times the side. When we are discussing perimeter, we are adding up all the sides. Take a look at what we see here for a rectangle. When it comes to the area, we are multiplying those dimensions together, the length and the width together. When it comes to perimeter, generally speaking, we're adding up all of those sides. Same ideas, everybody. Perimeter, add up all of those sides. For the area, we're multiplying dimensions together. Let me go ahead and draw another perfect rectangle because we know that I can draw very well. There we go. And when we write this out, let's write our length over here and our width right there. So, my friends, length times width, that's how we're going to get that area, that space inside right there. And here's the cool part. Here's the, I'm not going to say cool like I think math is cool, but I'm going to say the interesting part in terms of why we also see the formula for perimeters written in 2 different ways. Here's why. Everybody, help me out real quick. If our length down here is whatever it is, let's say it's 10 or 17 or whatever, where else is the length going to be the exact same? Where else? Correct, everybody. Perfectly stated. On the top. Exactly. Let me duplicate that right up there. And then same question. If our width is here on the right side of the rectangle, where else is that same width going to be? Correct. It's going to be on the left side because, again, the opposite sides of a rectangle, they're the same. Now, how does this translate to what we see here in these formulas? How does that translate? Well, the way that translates, everybody, is like this. When we are talking perimeter, pop quiz, everybody, in the chat box, how do we get perimeter again? For any shape, not just a rectangle? How do we get perimeter for any shape? Yeah, we get perimeter for any shape. Yeah, we're going to be adding up all of the sides. Exactly. We're going to be adding up all of the sides. Now, everybody help me out. When we do all of the adding, we have length plus width plus length plus width, and that's it. There are 4 sides. Can anybody tell me how many times the length appears? How many times does the length appear? Twice, right? Twice, exactly. When we add it up all the way around, we'll have length here and length there. So the length appears twice. Let me highlight that for us. Once there, and that's why we see 2 times the length. My friends, how many times does width appear? How many times does width appear? Yes, it appears twice as well. So if I highlight that here and here, guess what? That's where the 2 times the width appears. And then we add it together. We double the length, add it with double the width. And that's only because, everybody, the length appears twice, the width appears twice. So this is just shorthand for saying, hey, add up all the sides. There's 2 lengths and 2 widths. Add them all up, and that's how you get the perimeter. That's where that formula really comes about. It's just a shorthand way of saying length plus width plus width. Does this formula down here make a little more sense to anybody in terms of helping you memorize it? Good. Remember, everybody, it's not about memorizing the formulas. It's about understanding how they come about, where you can. Because some formulas are derivations of some calculus concepts, and, we're obviously not going there right now. But for the formulas that you can make sense of, I always encourage you to try to make sense of it. Understand those little pieces. So here's another one for the other formula here, the 2 times parentheses length plus width. You can use this one too if you'd like to. I prefer this one, but they both work just the same. And the way that this one comes about, let me go ahead and highlight the length plus width in green. And let me show you this. Length plus width. And then how many times does that appear? Twice. And that's where the 2 comes in. So if you add the length and the width and then you double the result, again, it's the same exact thing. Both of these mean length plus width plus width. You can just write it 2 different ways. Now, who here, what's your preference? Let me know in the chat box. Is your preference formula number 1 for perimeter or formula number 2? Which one's your preference? And it looks like we have a ton of people just trying to agree with me. Sounds good. I'm kidding. So yeah, number 2 is my preference as well, as I said. But again, remember, go with what works for you and you have to understand that both of these work just the same. So with that, that's it. That's it for the notes. We are ready to get to the examples and we're ready to start kicking some butt. So everyone, let's go ahead and review our basic strategy when it comes to word problems. Everybody, what's the first step, especially if you've been in my class before? What is the very, very first step with any word problem? Yeah, so for anybody here who is here for the first time and in our live class, and you see anybody saying RTQ, that stands for read the question. Now, that is not to say read the entire question first. No. The first thing you want to do is read the question sentence. So let me give you your first example here. So if, let's say we have this 2-sentence question, right? I don't care what this says. I don't care about that. I want to focus my attention immediately on the question sentence. Because remember, everybody, think about word problems in math, kind of like playing a game. Now, obviously, it's not the funnest game in the world, but what we can say about games is this. We don't like playing games unless we know what we're supposed to do to win. I'm part of people who agrees with that. Games are enjoyable when you know how to win. Cool. Yeah, like nobody wants to play a game when someone, when your friend comes over and says, hey, let's play this board game. And you're like, sure, okay. Then they open up the board game, they set up everything for you, and then they say start. And you're like, okay, well, how do I win? How do I play? And they're like, no, don't worry. Just don't worry about it. Is that going to be fun? No, it's not going to be fun at all if you don't know what you're supposed to do. It almost feels like you're being held hostage. So when it comes to word problems, treat it like a game. Why the heck am I sitting down? What's the goal of the question? And I know for a problem like this, it might feel pretty straightforward, but this is how you want to practice every single problem. Starting off right here, the question sentence. What is its area? Everybody, does knowing the goal before you look at the information help anybody out? Does that help you understand what we might need to do from the very get-go? I'm willing to bet yes. So let's get started here. Here's our first example. What is its area? Everybody, we have the advantage of having this hyper-specific geometry word, area. Whenever we see that, whenever we know we're dealing with a geometry-specific problem, you always want to ask yourself, if I'm looking for area or perimeter or volume, what shape? What shape? That's the first question you ask yourself after you know what the question is. What shape? Everybody, what shape are we dealing with in this question? Absolutely correct. Dealing with a square. It says it there in the first sentence. But the first thing we know is that we're looking for the area. Once we know that we want area, we know that there's a formula for it. We just need to know what shape. They reveal to us that the shape we're dealing with is a square. And from there, we see that it says, hey, if we want a square, we know a formula for it. Pop quiz, everybody. What is the area of a square? Appreciate you. That was quick, Luann. Yes, the area of a square is going to be the side times the side. Feel free to use your notes while we work in today's class. And so, everybody, are we given the side? A square has a side length of 7 inches. Do we have the side? Yes, we do. So this one's a very straightforward question. We just plug it in and we're done. 7 times 7, that's going to give us 49. And we are good. There's our area. Now, a follow-up question, pop quiz. What are the units that I'm going to include? Is the answer, since it's inches right here, is the answer going to be 49 inches? Is that the case for area? I got a couple of yeses, but then a ton of no's. Yeah, the answer is no. The correct answer here is no. When it comes to area, everybody, area's units are always listed in square units. So no, not centimeters, not feet. We're dealing with inches here, but the answer is going to be square inches. So we can write it like this, or we can write it as 49 square inches. Either way, we're saying the same exact thing. But remember, when it comes to area, we are dealing in 2 dimensions. We are multiplying this by this, so it's 2 dimensions. 2 dimensions, and that's why we have it as square inches. Now, everybody, am I giving this information right here for no reason at all? Is this important or not important? Who knows? Oh, I love that word. It's crucial. Yeah, it is crucial to make this distinction. Why? Because when you're dealing with a problem that gives you area to use, you need to be able to identify that you're working with area. So many people will look at area being given to them and they have no idea that they're actually being given what they need. They think that it's something else. So knowing the units you're looking at is imperative, everybody. All right, let's take a look at example number 2. Let's take a look here. Everybody, quickly tell me what we want. Read the question, RTQ. What is it that we want in this problem? Very quick reaction time there. Yes, we want perimeter. Right here, it says, what is its perimeter? Perfect. Let's write that down. We want perimeter. And everybody, generally speaking, when we're dealing with perimeter, we don't really need to know the shape. We just need to know the sides because we're going to add up all of the sides. Now, by that, yeah, sure, we're going to need to have a hint of the shape at some point, but the general idea is whatever shape we have, just add up all the sides. But we are given a specific shape in this problem, and that's going to be square, right there. So the perimeter of a square, pop quiz, give it to me in the chat box. What's that going to be? Correct. 4 times the side. So in this case, again, since we have 4 sides that are the same, 1, 2, 3, and 4, just multiply the side by 4. Yes or no, everybody? Are we given the side? Correct. We are given the side right here. Let me go ahead and change this to blue. But a side length of 5 inches. We're given it. So all we have to do is plug and chug. This one's a very straightforward one. We can feel good about it. Perimeter equals 4 times 5. 4 times 5 gives us 20, correct? Now I ask you again. I'm going to ask you again. Is it 20 inches here? Or would it be 20 inches squared for this one? Yeah, no, this one's actually just going to be regular inches. Now, I want to continue explaining this. Remember, everybody, when we're dealing with area like we were in this one, we are multiplying 2 dimensions together. So it's a 2-dimensional property, 2-dimensional unit, squaring the unit. Only for area, that's right. When we take a look at perimeter, my party people, are we multiplying all the sides together or are we adding the sides together? Correct, we are adding the sides. So just leaving it as inches is absolutely correct because we are adding this side plus this side plus this side plus this one. We're simply doing a little merry-go-round going from here and taking a lap. And we're just, we're going to add it all together to get the total distance. The distance from here back to the starting point. So when we're just adding it all up, no need to manipulate the dimensions because we didn't manipulate the dimensions. We just added dimensions. So again, for area, right over here, for area, it would be square units. For perimeter, it's just going to be regular units. Because again, perimeter is just distance from point A to point B, so just regular units. Area is square units because we are multiplying 2 dimensions together. Based off of this, pop quiz, who knows how we're going to state volume? Who knows this one? What kind of units are we using for volume? Yeah, that's cubic units. Exactly. So we would be using units cubed because it's 3 dimensions. Length times width times height. Multiplying 3 dimensions together gives you a 3-dimensional unit, a 3D unit, if that makes sense. So before I continue, everybody, does this satisfy just that innate curiosity of just the units? Because we're going to revisit this about maybe in like 5-6 questions, and you're going to see how important knowing this is. So for now, are we good before I continue? Right on, right on. So with that, let's keep the party going. So here's what I want you to practice. Number 1, tell me the goal of the question and tell me the shape. Here we go. 3, 2, 1, hit it. What is the goal and what is the shape? What is the goal and what is the shape? Yeah, so one thing I noticed is that a lot of folks here said perimeter. No, not quite. Everybody remember, the first thing we want to do is read the question. The question says, what is the length of one side? Who here sometimes feels confused in terms of when you see the geometry word appear, you think that you're calculating perimeter automatically? Yeah, so this is one of those common mistakes that I'm going to really help you avoid. I got your back, everybody. I got your back. No, I stopped that. I'm glad, Jaslyn. So with that, remember, we don't want to start by reading the problem. We want to start by reading the question. They give us perimeter. You're not looking for perimeter. They give it to you. The question that we're looking for is, what's the length of one side? So what we want is the length. That's what we want. And everybody, what shape are we given here? What shape are we dealing with? Correct. We're dealing with a square. So we want the length of a square. Sounds good. At this point, I don't know anything yet. I don't know how I'm going to get the length of the square. I don't know the information about the square. All I know right now is that I'm looking for the length of the square. When you try to do too much too quickly, sometimes it can really spell disaster, really. So let's understand what we might need to do here. I know that I'm looking for the length of a square. No formula is going to help me yet because I don't know if this is area or perimeter yet. But what I do see is that we're given the perimeter of the square. We are given the perimeter, and it's 32 inches. Everyone, quick question. Yes or no? Is there something that connects the perimeter of a square to the length of its side? Is there something, somewhere, some way, somehow that connects those two things? Oh, okay. Y'all seem confident. Can you tell me what that is in the chat box? What is that thing, that definition, that formula, quote, quote, hint, hint, wink, wink? What is the formula that connects perimeter and the side of a square? Can someone tell me the formula specifically? What is that going to be? Write it all out. Yeah. Perimeter equals 4 times the side. Remember, when we're dealing with a square, we have 4 sides that are the same. S for side. And so the perimeter equals 4 times the side. This is just using the information we have. Now, to follow up on that, I got to ask you this. Which piece of information do we know here? Which piece of information do we know? Yeah, we know the perimeter. What is that going to be? What is the perimeter that's given to us? Correct. That's 32. This is where we have to elevate ourselves in terms of interpreting information. Notice that we started off understanding that we needed the side of a square. Then we saw that we were given the perimeter. And so we know that the perimeter equals 4 times the side. Remember, this is what we're looking for, and this is what we have. So if I plug in 32 for the perimeter, look at what's revealed, everybody. Look at what we just revealed to ourselves. Everyone, are we working forward here? Are we plugging in the side to get the perimeter? Or are we working backwards where we're already given the perimeter and we got to find the side? There we go. Now we understand that this problem we are working backwards in. For those of us that were saying in the chat box that you believed that this was an area problem, for those of us that thought that this was an area problem, do we understand how this is not an area problem? Do we understand how we can actually use what we have to get this done? Good, because again, they gave us perimeter We know the formula for a perimeter, and we're looking for side, and we can get that with this now. So all we did first was plugged in the pieces that we have, perimeter, into the formula for perimeter. And once we did that, perimeter equals 4 times the side. Now, this is where we have to have an understanding, a little bit, of solving equations and working backwards. Because everybody, if I'm supposed to multiply the side times 4 to get the perimeter, what do I do to the perimeter to get back to the side? Correct, division. We must divide, and we must do it faithfully to both sides. Whatever you do to one side, you do to the other. So we'll divide both sides by 4, and that's all we have to do. That's all we have to do. It cancels out on the right side, giving us side equals 8 inches. And there we are. And there we are. This is an exercise in terms of using what we have and what we know to get what we need. So one more time, just to repeat the process here. This problem was not about trying to find the perimeter. This was about trying to find the side when you're already given the perimeter. So in this problem, we said, hey, perimeter, square, that's our formula. I know what the perimeter is, and I'm looking for the side. That's where I'm able to work backwards, dividing both sides by 4, to get rid of that 4 that's next to the side. Getting rid of it to get it by itself. 32 divided by 4, that's going to give us 8. And that's how we would get this done. Again, it's a very straightforward question once you know what you're doing. But this is the type of question that some of us may see on our tests, that if we don't understand that we need to work backwards, it can spell disaster on an otherwise straightforward question. Do we understand where I'm coming from with this? Even if you don't truly, totally understand what we're doing so far yet, do we understand that we're trying to understand working forward and working backwards with area and perimeter? Cool. As long as you understand the umbrella of what we're trying to do, I promise you, we'll get more and more specific, more nuanced, more detailed, and it'll get better as time goes on. But the main idea here is knowing how to use your formulas to work forward and backwards. Let's try this next one out here. Everybody, quick, tell me, what is it that we're looking for? What's the goal of the problem? Correct. This one, we're looking for perimeter. We're looking for perimeter. And just to remind y'all, I'm going to answer a couple of those questions that I saw in the chat box right after this problem here. I got you. So we start this one off, and we are looking for perimeter immediately right there. What is its perimeter? Boom. Okay, cool. Everybody, we know that perimeter just means add up all the sides. But if we have a specific shape that has a formula for it, we'll definitely want to use it. Everybody, is there a specific shape that we're given? Correct. That's going to be a rectangle right there. Given a rectangle. Now, would y'all kindly remind me, what is the formula for the perimeter of a rectangle? Again, be careful there. Formula for the perimeter of a rectangle. You can use your notes. Feel free. Use those notes. Yeah, so the perimeter for a rectangle, let me go ahead and write this down for us. Again, there's 2 different formulas for it, but they're both the same thing. There is the 2 times the length plus width. That's one formula. Or you can use the other one, which is my personal favorite. It's going to be perimeter equals double the length plus double the width. But nonetheless, everybody, let me just make sure I write adding. But nonetheless, everybody, all we're doing is just adding up all of the sides. That's all we're doing. So we have 2 of the lengths plus 2 of the widths. That's all that is saying. If you said length times width, that is the formula for area. Got to be careful there. Got to be careful. Let's go ahead and get this done. Everyone, are we given the length and given the width, or is there some work extra that we need to do here? Correct. Yes, we're given it. We're given both. So there's not much stress that we need to put ourselves under. We're good. So let's go ahead and plug in the values that we have. We have a length of 8. So I'm going to replace the length with 8. So let me just write perimeter equals 2 times 8. And then everybody, what value are we given for the width? Correct. We're given a width of 5 inches right here. Width of 5 inches. So what we'll be plugging in is 5 for the width, but don't ignore everything around the formula. 2 times 5. Let me go ahead and plug that in right there. All right. So from here, now that we have everything plugged in, the most important part about this is just knowing your order of operations. Really it. You really just have to know your order of operations. Let me zoom in a little bit, and here we go. We multiply first, and then we'll add the results after. Everyone, 2 times 8, hit me. Correct, 16. Appreciate you there. And then 2 times 5, I know. Sounds good, that's 10, perfect. And so when we have 16 plus 10, hardest math that you'll do all day, that's gonna give us what? 26, sounds good. And there we are. Now help me out, everybody. When it comes to perimeter, again, perimeter is just a distance. It's just a distance. So are we going to be using inches or inches squared? Which one? Correct. Just inches. Oh, man. So typically, when I run this type of class, this is the moment that we reflect on. This is the moment where if you understand the difference between the units, oh, man, when we get to those more complicated word problems that we're going to get to in just a couple of problems here, you're going to see how much easier your life is when you realize it's not just about the numbers, but it's about the story as well. So you're going to be feeling really good about yourself in a bit. So before we continue, I wanted to answer some of those questions from before. So I remember a question asking, hey, when we're dealing with area is the one where you multiply. Yes, area is the one that you multiply the length and the width together. Yes. When we're talking perimeter, that's the one where we're just trying to add up all the sides. Now, how we add up the sides, if we take it shorthand, yeah, you might multiply a length by 2 because there's 2 lengths, multiply the width by 2 because there's 2 widths, but still though, it's length plus width plus width. It's adding everything up. This is just a shorter way of doing it, but you're still just adding everything up. So does that answer your question from before? I think it was Eric that asked the question. Are we good on that before I continue? Sweet. Gotcha, Eric. And then, yes, this is the second question. So by Darren, Darren's question was, so if we have a house that can be made of different shapes, kind of like a square and a triangle, and they ask you for the area of like the front of the house, for sure what you would do, this is what's called a composite figure, quote unquote. So for those types of questions, let's say you have, again, something like this, and then you have something like this, and you want to find the area of the house. Yes, what you would do is you would split it into a square and into its triangle counterpart. And then what you would do is you would find the areas individually, and then you add it together. So let me know if that makes sense for you, Darren. Sweet. Sounds good. So with that said, everybody, let's go ahead and try this next one out. So everybody, before I continue to this next question, I want to prepare you. When it comes to using a formula, is it possible that you'll have to use it working backwards? Is it possible that you'll have to use it working backwards? Absolutely, right? Absolutely true. Okay, so with that said, y'all tell me, are we working forward or backwards in this problem here? Are we working forward or backwards in this problem here? Yeah, we're working backwards in this one, absolutely. And what are we looking for? What's the goal? What's the goal? When we read the question, what's the goal? Correct, the goal is the width. So again, we want to really turn our attention immediately over to the question sentence. Here's what it says. It says, if the length is 8 inches, what is the width? So right there's our question. What is the width? So you know those question action words. Who, what, when, where, how many, which of the following, right? Those are your question action words. What is the width? That is what you want to focus up on. That's your question. We want the width. Now, in that same sentence, everybody, what are we given? What did they give us in that same sentence? What did they give us in the same sentence? In that same sentence, not the question, in the same sentence, starting from right here. Yeah, they gave us the length, exactly. So we have the length, and that length is 8 inches, so I'll write that down right there. Now, there's one more piece of information that we're given, and it comes in that first sentence. What are we given in the first sentence, everyone? Correct, we're given the perimeter, and we're also given the shape. What's the shape? Correct, a rectangle. So we have all of these little wins that we're piling up. Trust me, everybody, the information collection process, collecting information, This is the most important part because this is the difference between assuming that you need the area formula versus correctly deducing that you need to use the perimeter formula. We're given the perimeter. The perimeter here is 24 inches. Everyone, is there a formula that can connect the perimeter and the length to the missing width? Is there a formula we can use for this? And if so, write out that formula. Give it to me. What is that formula going to be? And notice when I say write the formula down, I mean everybody write that formula. It's always those of you who take the time to write things out the right way. It's always those of you that do that gain the most from these classes. So Nicole, appreciate you right there. Yes, that is that formula that I would absolutely recommend. The perimeter of a rectangle, that formula is 2 times the length plus 2 times the width. That's your formula. Again, that's one of the 2 formulas you could use for perimeter of a rectangle specifically. But there you go. Notice that we did not say area. This problem did not give us area, and therefore we should not be using the area formula because we don't need it. We don't need it. We want to use the perimeter because we're given the perimeter right there. So does that make sense to anybody here who's been struggling to pick which formula to use? You know, the problem, the actual information is really what you want to look at before you make your decision. It'll always guide the way for you. Okay. So now that we're here, we know that we're looking for the width. This is what we want right there. What do we do for everything else? What do we do with this and this? What do we do? That's right. We're going to plug in the numbers. Just plug in what you have, everybody. That's all you got to do. Plug in the information. So with that, everybody, what was the perimeter of this rectangle that we're given? What was the perimeter given to us as? Correct. 24. That's right. Let me highlight this in blue. 24 right there. 24. Then we're looking for the width. So we need to plug something in for the length. What are we plugging in for the length? That's right. We're plugging in 8. So notice we're doing the same stuff. We're assessing what we have, assessing what we want, plugging in the given information, and then calculating the rest. Watch this. 2 times the length, which is going to be 8, plus 2 times the width. And with that said, everybody, what is 2 multiplied by 8 going to be? Let's kind of, clean that up real quick. What's that going to be? Yeah, 16. 2 times 8 is 16. So we now have 24 equals 16 plus 2 times that width. So this looks a little funky, right? It's not as easy as the one before. It wasn't just one step and it's all taken care of. But let me go ahead and just give you a quick reality check. Not every single problem is going to be 1 or 2 steps. Like, I got to be real with you. If we are going to give up after a problem takes more than 1 or 2 steps, that's just not how it's going to work. Just not how it's going to work. We have to work backwards. We know we're doing the right thing. We're working backwards to get the width, and we have to customize ourselves to the process. Solving equations, if this is tough for you, write this down. Solving equations is something you need to be proficient in. Again, solving equations. If you're a little nervous about this part, which I suspect a couple of us are, and it's okay, absolutely okay, make sure you familiarize yourselves with solving equations. Let's continue here and let's solve this. I got you. So the goal is to get the width by itself. I have a 16 here and a 2 here. To work backwards, we want to start by getting rid of the number that's furthest away from what we want. The 2 is attached. It's multiplying. The 16 is just sitting there. How do we get rid of a 16 that's just sitting there? Correct. Subtract it, and thank you so much. I got to shout you both out. I'm going to shout out Giancarlo and Amber, both for saying from both sides. Jaslyn, you as well. Yes, from both sides. I'll subtract 16 on the right side and on the left side. And once we do that, correct, Andrew, we are balancing the equation. Once we do that, cancels out on the right side. 24 minus 16 is going to give us 8, and that's going to be equal to 2 times the width. We're still working backwards here. And so everybody, how do we work backwards to get rid of that 2? Yes, we'll now work backwards from multiplying by 2, and we'll do that by dividing by 2 on both sides. There we are. So once we do that, cancels out. We now just have the width by itself, and that's going to be equal to 4 inches in this problem. And there we go. So who here was looking at this part in the beginning of the problem, or even this part, and who here was looking at this and thought, ain't no way I'll be able to do this. Ain't no way that this will get done. Now, after you've seen it get done, do you now realize that it's perhaps a little easier than you might have thought? Right on. Remember, everybody, one of the things I like to live by is everything feels impossible until you see it done or get it done once. Then it's just challenging. And then from there, we want to turn challenging to easy through practice. So again, it's impossible at first, then it's doable, and then it's easy. It takes time, but you can get there. You can absolutely get there. So working backwards is just like solving equations with this. We're just solving equations. So if this is something you're struggling with, that's something I would definitely, circle so you can practice on your time. Let's go ahead and move forward here to the next one. Let's take a look at this one here. My party people, tell me, what is it that we're looking for? What is it that we want? Yeah. Immediately, we know that we want the area. Now, I'm going to reiterate this. I'm going to say this again. This is one of the advantages that you have when it comes to geometry word problems. One of the advantages that you have is when they use hyper-specific terminology like perimeter, area, volume, surface area. You want to ask, well, what shape? That's the first thing you want to ask yourself. As soon as you know that you're dealing with a geometry problem, you want to ask yourself, what shape? Question, everybody, what shape are we dealing with? What shape are we dealing with? Yes, it's a rectangle right here. Now, what I want everybody to do in the next 10 to 15 seconds, type the formula for the area of a rectangle. Go. Let's practice this. Go, 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 go. Give me that formula. Yes, area equals length times width. Correct. Give that entire formula. Because again, the hint is right there in the context. It's not the numbers. It is the wording. Area of a rectangle. So what I'm going to do is I'm going to immediately, knowing that I'm dealing with the area of a rectangle, I'm going to write the formula for the area of a rectangle. That's the advantage you have when it comes to geometry. The moment you know you're dealing with that hyper-specific formula type word, boom, write that formula out. And now that we know we're trying to find the area, your goal is to find the length and find the width. Luckily, in this question, they give it to you. We get the length of 9 inches and the width of 4. So all we got to do is just plug this in and move on, and we're fine. We're good. But for a problem that gets a little tougher, we got to keep a lookout. So here we go. Area equals, the length was 9, the width was 4. Everybody, the answer here is area equals 36 inches. Is that correct? Correct? Yeah, right? 36, right? 36 inches? Yeah, incorrect. Incorrect. Yes, the number, the value 36 is correct. That's absolutely right. But the units are inches squared, or square inches in this case. So you'll write it as 36 inches squared. You can say 36 in squared, or you can say 36 square inches. All of these are saying the same exact thing. Notice how I'm emphasizing heavily the units, because we're going to step into some questions that are going to require you to understand the units, because it won't tell you area. It won't tell you perimeter. You have to realize it. So with that said, everybody, I think at this point we've gotten enough practice. Who here is ready to start doing some multiple choice questions? Hey, right on, right on, right on. So with that said, let me go ahead and prepare these questions and we'll get started. And I'm going to actually put these questions on a timer. That way you can feel free to try these out just like it would be on test day. If you're watching this as a recording, I just recommend that you set a timer up on your own with your phone or your watch and give yourself about 2 minutes and 30 seconds per question. So here we go with our first one here with the multiple choice. So the question reads, what is its perimeter? Everybody, when we're asking for perimeter, again, one of those hyper specific geometry words, what shape are we dealing with? Yeah, dealing with a rectangle here. So again, we can always default to, just add up all the sides of the shape. But given that we're, given a rectangle, well, we have a formula for that. And we can definitely take advantage of that formula. Perimeter equals 2 times the length. Because again, there's 2 lengths that we add along with 2 widths that we add. So that's how we'll get this going. So with that, we're going to go ahead here and just plug and chug if we have the information. So we see that it says length of 14 centimeters, width of 6 centimeters. Everybody, question, do we have everything we need to just plug away and calculate? Correct, we do. Notice how I'm asking these very straightforward questions. Some of y'all might even call it easy questions, but it's so important to ask these questions for the easy ones and the hard questions, because this is how you'll stay grounded. This is how you'll feel confident. That's where it comes from. So plugging in the length, plugging in the width, and let's get it done. Length was 14, the width is 6, and here we go. 2 times 14 plus 2 times 6. Add everything up once we multiply. So 2 times 14, that's going to give 28. 2 times 6, that's going to give us 12. And once we add these 2 values together, we're going to end up getting 40. 28 plus 12, that's going to give us 40. And that's going to be answer choice B. But pop quiz, my friends, is that going to be centimeters or centimeters squared? Which one of them is it supposed to be? It's regular centimeters here because perimeter is just distance. Perimeter is just distance, not area, not space that we're covering. So excellent work, everybody. Excellent job. Are we ready to try another one out? Hey, I love the confidence. Sounds good. Let's go ahead and give it a go. So again, the wording is more important than the numbers. Let's go ahead and see how that applies to this one. Everyone, what is it that we are looking for in this problem? What's the goal once we read the question? When we read the question, the goal is to get the length. It says again, hey, based on the coverage provided, what is the length in yards of one edge of the backyard? Edge meaning a side. Again, just one of the sides is what we're looking for. So let's go ahead and highlight that right there. And again, specifically, what is the length of one edge of the backyard? So, question, everybody. We have that down, right? We're just looking for length. That's all we need. Obviously, how we get there is going to be a little bit of a game, but we are indeed looking for length. Is that correct? Right on. So let's write that down. I want to know the length. Now, because I did just state a slight geometry word, right? Let's understand the context here. Everybody, what shape are we dealing with here? What shape? Correct, we're dealing with a square. That's told to us right here, a square backyard. Okay, great. We want a square backyard. Perfect, there it is. And so here's where things are gonna get confusing. Let's read here. We know that we want the length of this square, but how do we get there? A square backyard is fully paved with decorative tiles covering a total of 64 square yards. One side of the square is unknown. Based on the coverage provided, there's our question. But let me read that again. What happened here? A square backyard is fully paved with decorative tiles covering a total. I don't care about all that. If, who here is looking at this screaming, what the heck? Why is it not saying area? Why is it not saying perimeter? I am now confused. Who felt that way? Who felt that way reading that and you're like, it didn't explicitly say it, so now I'm confused. Yeah, so this is where, that's a lot of us. So I know, probably all of us, it's all good. But this is where we raise those scores. This is how we score higher and get hired. This is how we do it. Look at this, everybody. What have I said here? When we take a look at the value that we're given, covering a total of 64, I'm not even gonna highlight the number. I'm gonna look at this right here, square yards. Everybody, I'm not gonna say that I said this once or twice, maybe a dozen or 2 times. What did I say about square units? What does that represent? Yes, area, area. This right here is area. That's the biggest point. I warned you, right? I warned you at the beginning of class, during our notes, during the examples. I warned every single one of you. So I don't want anybody here giving me the side eye. Number one, it's virtual. I can't see your face anyway. But number two, I don't want that kind of negativity. So with that said, let's go ahead and write this down. We are given the area here. The area is 64 square yards. Because again, it is area because it is square units. Square units means area. Square units, again, yards squared is area. This is your biggest introduction to this concept here. Making this mistake right now is much better than making the mistake on test day. So, as frustrating as it might be to not get it right, don't worry. We're learning. We're good. You have every chance. So with that, everybody, since we know we're dealing with area, since we know we're dealing with a square, would you kindly tell me what the area formula for a square is? What is the formula for the area of a square? Yeah, side times side. Or the other way of saying it is side squared. But yeah, they both mean the same thing. So here we go. Our area formula for a square is equal to side times side. You could also say side squared. Both ways, they're the same thing. You're good. But there we go. Everyone, what are we going to replace the area with? What are we replacing it with? Yeah, 64. Remember, we identified the area as 64. So with that, there we are. Boom, 64 equals side times side. Everybody, if we just look at this, we might be able to figure this out. What number do we multiply by itself to get a 64? What times what gives you 60? Yes, 8. 8 times 8 is indeed 64. And so with that said, we can now say confidently that the side equals 8 yards. And there we go. The correct answer is D, 8, not A, 16. If you assumed that this was perimeter, you would have gotten A16 because you would have divided by 4 and it would have led you astray. And I put that answer there on purpose to, again, teach you a lesson and also chuckle to myself in the background, knowing that I got you. So with that, my party people, I'm obviously kidding about that last part. But with that said, how are we feeling though? Especially those of us that made the mistake. Are you able to truly see where I'm coming from now when I said that the units matter? Awesome. Sounds good. Sounds good. So all jokes aside here, I appreciate y'all being patient with that. I appreciate y'all being willing to learn and learn through those mistakes. Now let's go ahead and move forward to the next one. Let's keep having fun. So let me go ahead and pull the next one up here and we'll get started momentarily. And let's go ahead and move forward here and get into this one. So everybody, as I begin this problem here, a rectangular playground is being outlined with a, what am I doing wrong? What am I doing wrong, everybody? Yeah, we want to start off always by reading the question. Again, give yourself the opportunity to settle into the game by understand what the game is about. So what is this game about? The game is about figuring out what is the length of the adjacent edge. Okay, I don't know what that means, but that's the goal. The goal is to figure out what this length of this adjacent edge is. Okay. Whatever we do to get there. All right, cool. So let's highlight that. What is the length of the adjacent edge? And adjacent just means connecting. So if we say that one edge measures 12 feet, so let me just highlight this in blue so I can explain what this means. We already know that we're talking about a rectangle right up top, so let me just assume that to help you out. Let's assume the rectangle looks something like this. If they say that, one of the edges is 12 feet over here, adjacent means the one next to it. So if this is one edge, the adjacent edge would be either this one or this one. Does that make sense, everybody? Just to explain the word adjacent to us. Adjacent means, again, connecting, next to, in succession, basically right next to. Cool. Sounds good. There we go. So does it matter which one we choose, everybody, or is it going to be the same one either way? Based on what you know about the opposite sides of rectangles, does it matter which one we think about? Exactly. The answer is it doesn't matter, because we know that if this is the length, then this is also the length. So it doesn't matter. It doesn't really matter at all. So let's go ahead now and understand the information at its fullest so we know what we're supposed to do. Now, you're going to notice that we have the same exact headache as the previous question. Watch. A rectangular playground is being outlined with a 50-foot long string of lights that run along its entire boundary. My party people, they didn't say perimeter. They didn't say area. But they definitely said one of those things. Which one are we saying? Which one is it? And you got to give me proof. You got to give me evidence. You can't just throw perimeter out there. Come on, man. I'm not going to follow along blindly. Give me a reason. Yeah, and it's going to be a phrase. There we go. Yes. The phrase that we're looking for, the key phrase, the key words here. I'm going to highlight this in green. And it says this. Yeah, sure. You have your 50-foot long string. Sure. Let me just underline those. But here we go. It runs along its entire boundary. Everybody, when I act that out, let me just erase these red highlights here. When I act this out, what does it sound like I'm talking about? If I'm going along the entire boundary of a shape, what does that sound like to you? Area or perimeter? Oh yeah, that's perimeter all the way. So we have yet another example where it's way too important to understand the words that we see. If we were to make the assumption that this was area, hey, would have been a bad time, would have been wasting time. But because we know that this runs along the entire boundary, that is perimeter all the way. Yeah, because it's on the outside of the shape. So now that we interpreted and translated those keywords, now we know that this 50, it's the perimeter. We're using a rectangle here. We have a rectangle. We have its perimeter. It's 50 feet. We have one of the edges. We're looking for the length, so I'm just going to call that the width. We have the width of 12 feet because, again, we're looking for the length right here. So I'll just call the other one the width because I know that it's a rectangle, so whatever. But there we are. We have a rectangle. We have the perimeter. We have the width. My party people, can we find the length? Yes, we can. From here, we absolutely can. Let me take this up a little more so I have more room. But when we talk about the perimeter of a rectangle, the formula goes as follows. Perimeter equals double the length plus double the width. Again, just add up all the sides. There's 2 lengths and 2 widths that we're adding together, and that's all that shows. Let's plug everything in, and we are good. Here we go. Everybody, the perimeter that we're plugging in is what? Give me the perimeter. 50, correct. What are we plugging in for the width? Give it to me. Correct. We are plugging in 12. So 2 times the length plus 2 times 12. So I'm going to highlight what we've plugged in. We've plugged in the 50 and we've plugged in the 12. Now we just have to find that length. And this is where it turns into translating the English into math. And now we're going to actually do the math. So if this is, again, where you're getting stuck, where you're getting a little confused in dealing with the equation, remember, you have every opportunity and ability to practice this. Do your thing. Let's clean things up, everybody. 2 times 12, what is it? 24, correct. So now we have 50 equals 2 times the length plus 24. Now that we're here, again, the goal is still trying to get the length by itself. We're trying to figure out what length equals. I got the 2 in the way. I got the 24 in the way. Remember that we always take care of separated or isolated numbers first. So we see plus 24. The opposite is subtract 24. Nice and easy. So now that we did that, it's going to cancel out on the right side. And we have 50 minus 24. Everybody, 50 minus 24 off the top of your head is what? 26, correct. So we have 26 equals 2 times the length. And now the last thing we have to do is divide both sides by 2. Boom. So once we divide both sides by 2, that's going to give us the length equals what? Yeah, 13. And there we go. There's our answer, 13. 13 feet. Oh yeah, everybody. And the correct answer here is C. So again, let's kind of reflect real quick. Who here feels like they're starting to understand, reading the words and turning that into area or perimeter or the right thing that we're talking about? Who here is really starting to, have those gears turning in that respect? Again, I'm not asking you if you've perfected it. I'm just asking you if you've been annoyed to the point where you're now starting to see what I'm talking about. All right, good. So again, just to recap here before I move forward, the problem here was we wanted to find the missing side of a rectangle. We had the width. We were looking for the length. What we needed to do here, the biggest piece of this problem in green, right here, in green, this green highlight, was interpreting whether this 50 was the area or the perimeter. That was the biggest part. And when we read the green highlight here, it says this string of lights runs along the entire boundary or the entire border. That is your tell. That is the biggest hint that we're dealing with perimeter that runs along the border of a shape versus area that would be covering the entire space. We're not talking about the space inside. We're talking about the border around. And that's how we knew that we were dealing with perimeter. Once we understood that, the rest was easy. It was just plugging into our formula and then just solving from there. But indeed, still, this is the biggest part. Understanding the words as math. And Chad, yes, using the word outlined, like if we say, yeah, this property is outlined with a fence. Oh yeah, you're talking about perimeter all day. All day. Yeah. So with that, everybody, who here is feeling a little better? Who here is ready for the next problem? Perfect. Sounds good. So let me go ahead and grab this next problem and let's get started here. We have enough time, I believe, hopefully for 2 more. At the very least 1 more, depending on how long it takes us to solve it. But we should have at least time for 1 more. All right, let's give this next one a shot, everybody. So, as always, we begin by reading the question. Again, give yourself the best chance of success by beginning with the goal. Here's the goal right there. What is the width of the garden? I don't know anything else about this problem. I don't know anything else. All I know and all I care about here in the beginning is that I'm looking for the width of this magical garden. I mean, it could be a square, it could be a rectangle, it could be a triangle, it could be whatever. It doesn't matter. All I care about is the width. So let me write that down. Width equals blank. Now, the next thing I'll do is I'm going to begin from sentence 1, the beginning sentence, and I'm going to slowly gather the information. If I see someone or something that doesn't make total sense, I'm going to analyze it again. So this is what you want to do. Here we go. Consider a rectangular garden with a length of 12 feet and an unknown width. You don't say, I'm looking for that width. Okay, so I don't need to really dive into that because, yeah, the width is unknown. But here it says the length is 12 feet and it's a rectangular garden. So that's really good information that I can pull. Rectangular garden, length of 12 feet. So let me write that down right there. And again, we have this rectangle. Cool. The next thing I'll do is move on to sentence 2. That's it. Sentence number 2 says, a gardener walks completely around the garden, covering a total distance of 34 feet. Okay, everybody. Do you mind telling me what the heck I just read? What does that mean? I'm confused. A gardener walks completely around the garden. I mean, why is he taking a break? He's supposed to be working. Come on. What does that mean, everybody? There we go. Perimeter. Yes. Perimeter. Walks completely around the garden. Around the garden. Covering a total distance. Not total area. Total distance of 34 feet. Sure, I know we see the word covering here, which most times covering might indicate area, but we are very specific here in the sense of this gardener walked around and covered a distance, not covered a total space. If they said that the gardener walked into the garden and noticed that it covered 34 square feet, the square feet would be what gave it away. But notice that it did not say square feet here. It just says 34 feet. So before I continue, Do we have a reinforced or a strengthened understanding in terms of noticing that this is perimeter, not area? Awesome. And it takes time, because is this the only situation we can deal with? Absolutely not. We can deal with gardens, we can deal with property, we can deal with paintings, we can deal with interior design, we can deal with really anything. So we just have to let each situation reveal its contents. That's what it's about. So with that, here we go. We are given the perimeter, that total distance of 34 feet. So perimeter equals 34 feet. Okay, so now what I'll do is I'll set up my formula and plug and chug. Let's get it done. The perimeter formula for a rectangle is going to be 2 times the length plus 2 times the width. Let's plug in everything we have. Let's get this done. Everybody, the perimeter that we're given is 34, so we'll plug that in. The length that we're given is 12, so I'll also plug that in, 2 times 12. Then we'll add that in with the rest of the information. And now from here, we'll just continue on by cleaning things up and seeing what we can do. 2 times 12 is going to give us 24. So we have 34 equals 24 plus 2. From here, we'll just take a moment to analyze, and we notice that we're trying to get W by itself. So I'm going to need to get rid of the 24 and the 2. The 2 is attached at the hip to the W, so let me ignore that for now. Let me get rid of the 24 right here. Correct, Giovanni? We're going to subtract 24 from both sides. Nice and easy, there and there. And once we subtract, cancel out, nice and easy, get 10 on the left side equals 2W. Now don't get confused, because we see a 10, that does not mean that the answer is 10. We're not done yet. We don't have W by itself yet. We still need to divide both sides by 2. That's correct. So once we divide both sides by 2, there we are. Booyah, cancels out on the right side, giving us W equals 5 feet. So the width here is 5 feet. And there we are. We're all set. And the correct answer is B, 5 feet. So there we go, everybody. Who here got this one right? How do we feel after going through all of these questions? Who feels like they're trending in the right direction? Let's go. That's what we need to aim for every single time we study. I'll leave you with this bit of advice here. Remember that your goal, every time that you go through a study session, your goal is, before you move on with your day, your goal is to be able to explain, to discuss, to talk about the things that you learned, the things that you did, the mistakes that you made, the understanding that you now have. You really need to prioritize being able to discuss and talk about what you do. That's really it, my friends. Great class today.